Good evening, folks, and welcome to the Advent of Code C++ live stream. My name is Craig, and tonight, as every night, we are going to be working on solutions to the new Advent of Code puzzles in C++. Thank you to everyone tuning in, whether you're watching on the Twitch live stream or you're watching the replay later on YouTube. If you're watching on Twitch, you can just head to my channel description, and you are going to see links to the YouTube channel that has the replays and to the GitHub repo where we put all the code that we write. If you're watching on YouTube, you'll find links right down there in the video description to the Twitch channel for live streams and once again to that GitHub repo that has all of the code. So we have about 3.5 minutes until tonight's puzzles drops. We're at day 13, about halfway through the Advent of Code sequence of puzzles this year. So, things are starting to get a little more difficult, a little more interesting. We had an interesting kind of pathfinding problem last night. And, things might start to get a little tricky as we go on here. Like, in the teens, I've definitely seen previous years some problems where, like, a brute force solution isn't efficient enough to solve and you need to come up with something more clever, whether that's, a better algorithm or just using something like dynamic programming to remember the things that you've already solved. Who knows what we'll find this year? We may also find, some problem that, that requires some modular arithmetic or some math tricks that I don't remember super well from my discrete math class when I was an undergraduate. So, as always, I make no promises that I won't get stumped by one of these puzzles, but I'll try my best, and we'll see where we get. So, with just about 2 minutes to go, I've already got, just the skeleton of a solution set up here for day 13. We've got a very basic C++ program that doesn't really do anything. We've got our main function. It just returns 0. I do have it include my little check library and my IO library because, as I've said on previous streams, we wind up using those pretty much every day. Check just does assertions, and the IO library we use to read in and parse the file that we get as our puzzle input. And I've already set that up to build here using the Bazel build system that we're using. So we might as well just give it a run right now, as is. So config equals LLVM because I'm using toolchain setup for the LLVM tools instead of the GCC tools. It's kind of a matter of personal preference, but I like the LLVM stuff better. Opt just to do an optimized binary, and we will just give it the path to our part 1 target. And Bazel's going to start up, build it, and run it, and there's no output because the program doesn't actually do anything yet. It just returns 0 to the calling environment. So we have all that set up and ready to go, and we have about 25 seconds until tonight's puzzle drops. So our submarine is slowly winding its way through this cave here, and we'll see where it ends up in our quest to find the overboard sleigh keys. I always really do appreciate the ASCII art picture that kind of develops day by day. Okay, let's get into it. Transparent origami. You reach another volcanically active part of the cave. Be nice if you could do some thermal imaging so you could tell ahead of time which caves are too hot. Okay, we are equipped with a thermal camera. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual. Apparently, elves have never used it. You manage to find the manual. As you go to it, page 1 falls out. It's a large sheet of transparent paper. The transparent paper is marked with random dots and includes instructions on how to fold it up. Okay. First section of list of is a list of dots on the paper. 0, 0 is top left. First value x increases to the right, etc., etc. Second value increases downward. Okay. So coordinate 3, 0 is to the right of 0, 1. Yep. Okay. Then there's a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper up for horizontal or left for vertical lines. Okay? Because this is a horizontal line, fold the bottom half up. Okay? Now only 17 dots are visible. Dots may end up overlapping, but they will never appear exactly on the fold line. Notice, for example, 2 dots and okay. Dots can end up overlapping. In that case, they merge together and become a single dot. Okay, so let's get our puzzle input and see what it looks like. So we're doing some more 2D geometry, but stuff that isn't necessarily programmed into my little 2D geometry library yet, but we can probably use some of that stuff. So I'm going to take a look at what that day 13 input looks like. So we've got a list of coordinates. Just given as coordinate pairs. And then we've got this fold instruction. So, yeah. Okay. So I am going to use at least some of my Grid 2 geometry library. And let's read in the input as a vector of strings to start. We'll use read lines from file and do the first argument to the program as the file name. And then the other thing that we can do is there's another thing here where we can split by new lines to split the fold instructions from the coordinates, the coordinate pairs. So let's go ahead and do that right now. Split by empty strings, and we'll move the input there. Actually, you guessed wrong, autocomplete. I wanted the move from utility, not from algorithm. Okay. So we should check that there are two pieces there. One for the list of instructions and one for the list of coordinates and one for the list of fold instructions. So I am just going to initially put all of the points into a set. Just keep track of all of them, and yeah, I'm going to treat this in a sparse way rather than a dense way. I mean, we could go either way and get a correct solution, but that is what I am choosing to do right now. So I'm going to use the little point struct that I've already written. And we'll go for those point strings in the first half of the split. Each one we should be able to split by a comma and then say, I'll say standard vector of string views for the coordinate strings, and we'll use stir split on the point string, splitting by the comma character, And then the first one should be X, the second one should be Y, but we'll just double check that that we do split into exactly 2. And then we will go ahead and do the parsing. So we'll use int64. Even though these numbers are relatively small, my little geometry library uses int64 for the coordinates anyway. So that is what we are going to do. So we'll check absal simple a2I, where we'll parse the first one. Or actually, you know what? We'll just use a point, and we'll parse directly into the X and Y fields in that point. So we'll check that we can parse X, and do the same thing with the second of the coordinates to parse Y. That's all good, and then we will put that in to the set of points. So we've got our big set of points, and then, well, we know that it means fold X along 655, but basically we need to do a reflection of these points. So we'll say if I mean, honestly, we might as well get a head start on parsing the fold instructions anyway. So we'll make a little class to represent a fold, or just a struct, really. So whether it's it can be over X or Y. And get a particular value there. So, excuse me. So we'll have a vector of folds, and we'll go ahead and parse those out right now. So that's from the back of the split, and can count characters here. I'm going to be real net. No, that's not what I wanted. But basically, that's going to be 5. It's going to be 10, 11, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So position 11 should be X or Y. Then fold.x equals true. Else fold, well, it better be y in that case. So we'll check that. And we'll put fold.x equals false. And then we will go ahead and check that we can parse the value along the rest of it. We should have pre-initialized that to something. Yeah, but we'll check absal simple a2I on the substring of the fold string starting at 13 should be correct. And we'll parse that into the value part field of folds. Okay. Then we'll just okay. So now we need to actually apply a fold. So to do that, we basically reflect stuff that is, to the right or to the bottom of a given dot across that line. So yeah, so let's go ahead and write a function called ApplyFold that will do this, and it will take as input the set of points, and it will give us a new set of points as the output. Clean that up some. Okay. So, we'll say for well, we'll have a set of new points for one thing. Points after the fold, essentially. So for point in the original set of points, got to keep remembering to prefix this, or I guess I could use a using statement, but in for a penny, in for a pound on the fully qualified names, I guess. Grid 2, there we go. Okay, so if we'll say, oh, and of course we've got to actually have the fold too, don't we? So we'll say const fold and fold. Okay, so if fold dot x means we are folding over the x, so over an x line, meaning that things to the right of that will go to the left. So if points should never be exactly on the fold line. So let's go. We got that from the problem description. So let's go ahead and say check fold.x does not equal well, let's check that points does not equal point.x does not equal fold.x. It will be to either side. It will not be exactly on the fold line. So if point.x is less than fold.x, the point stays where it is. So we'll say new points in place point. Otherwise, it must be greater than the fold. So what we need to do is calculate how far to the right of the fold it is, and then put it that far to the left of the fold. So we'll say an int64t for the distance, and that is going to be point.x minus fold.x, or not, fold.value rather. Yeah, all these should be fold.value. I don't know why it hasn't even complained about that. Oh, yeah, because fold.x is a thing, but it's a Boolean. Gotta watch out for those implicit type conversions in C++. They'll get you every time. So the new value for the point is going to be so we'll call this folded. And we will initialize it as the point that we've already been looking at. But then folded.x is going to be the value of the fold minus that distance. Because, we're flipping it, how far it was over the right, it's going to be that far left of the fold. And then we will go ahead and put that in that folded point in new points. And if we're folding over the y, this is going to be very, very similar. We're just going to do it in the y dimension instead of the x dimension. So I'm going to do, with your indulgence, good friends, do a little copy pasting and just change x's to y's. And then return new points. Okay. So we've got our ApplyFold function. And the only thing that we need to do is just how many dots are visible after completing the first fold instruction on your transparent paper. And if dots ever overlap, they'll be taken care of by the set semantics. Just, when we try to emplace something that's already there, it won't duplicate it. So we'll say for the result, all that we got to do is do apply fold with that set of points with the first fold and then get the size of the resulting set. And include IOStream. And now we just need to add the dependencies. We used flat hash set, we used strings from absal, and we used my 2D grid library. Well, we can just copy paste here and get these in. So let's go ahead and try and run this program on our day 13 input. It says 428. So we'll see if that's correct, or maybe I made a mistake. We'll see. Okay, not correct. So I kind of wasn't necessarily expecting that I made no mistakes on that, but let's see. Just going to make sure that I parsed folds correctly. I'll check that first, I think. Just checking that that is as expected. Okay. That all looks correct. Oh, that's chords.back, not chords.front. See, it'll be something simple like that. Bad parsing logic, but let's run that again, and that should give us the correct answer now. 661. Let's see about that. No. Bingo. Okay, part 2. Finish folding. The manual says codes always 8 capital letters. Okay, so now we just apply our ApplyFold function a bunch of times and try and render it out as output. So let's go ahead and do for fold in folds. I hope you don't mind that I'm just reusing part 1 here, because we already got quite far along to where we were supposed to be. So we'll say points equals ApplyFold. We'll move the old version of points in there and apply that fold. And then let's just put in another function that does a nice render. Of a set of grids. So first thing we ought to do is go through, find the maximum x and y for how big this thing that we are putting together is. And then for each point in points, max x is going to be max of the existing max x and the point's x value. Similarly, max y is going to be the maximum of the existing max y and the point's y value. Okay. So now we are going to make a vector of strings, and each string is going to be one line. So the way that we're going to do this is the number of elements in the vector is going to be max y plus 1. And each one of those elements is going to be a string of max x plus 1 length. And we are just going to put those as spaces for now. And then anytime we have a point and a place, we'll change it to another character. So we'll go for all of the points in the set of points, we are going to take that view, and the view is going to be y major first, because that's going to be the outside line of it. But we'll say view point dot y, and then the x coordinate is going to be the position in the string, point dot x, and we will make that, let's say, a pound sign or a hashtag, depending on your generation. So we do that, we render all those points, and then we'll just say for each line in the view, print out that line followed by a new line. Okay, so we've got our render function. At this point, we've applied all the points, so we'll just say render points. Let's see what that gives us, what that looks like. Okay, that looks like some letters, doesn't it? So I'm going to go ahead and put those in. That looks like P, F, K, L, K, C, F, P. Bom bom! We got it, folks. We did some origami today. Let's see what the score was. Okay, pretty decent. Not quite as blazingly fast as yesterday, but I feel pretty good about this. I feel like maybe I might want to bake some of this into the geometry library that I've been working on, at least the ability to do reflections across a line. That seems kind of useful. Yeah, but yeah, I feel pretty good about this. I mean, already having that point class written, which is, a type that, provides the X and Y and is hashable, we can use it in that set-based container, that seemed to work pretty well. Now, we could have done another approach to this problem. We could have done a dense grid to represent the points instead of just keeping them in a set. But I get the feeling that probably at least in the initial set of points, um, that's probably pretty sparse in that huge size of the grid. So I think the set based approach was still the way to go. But yeah, feeling pretty good about this solution. Once again, all the code that we write goes up onto GitHub. So if you are looking for the link to that GitHub repository and you're watching on Twitch, you can find it in my channel description. If you're watching on YouTube, that'll be right down in the video description right there. Thanks again for watching, everyone. I hope you had fun tonight, and I hope to see you again tomorrow night when we tackle Day 14's puzzles. Bye-bye, everyone.